Okay, so let's start. Okay, so for the first question, we have a summation, method of differences. So of course, that means we have to do some partial fraction, right? We have to partial fraction this sum, well, the inside of the sum, the expression in the sum, and then see if we can cancel things out by this method of difference. So let's do that. So let me write it down first. AR plus 1, AR plus A plus 1. Well, of course, we can see that we can just split this expression into two parts. Well, into these two guys. Actually, I shouldn't put the 1 here. Just put AR plus A plus 1. Now, how do you figure out the constants up here? It should be A and B, right? Because the R is just degree 1. So A and B. Now, how do you figure out A and B without doing any, cross multiplication, equating coefficients? We can just do it by inspection. Let's say imagine that it is both are 1 here. Well, if you're going to combine these two guys on the right-hand side, you get this guy up here and this guy up here, right? If you combine the fraction. But then you will get like 2AR plus A plus 1, which you don't like. So what you want is to cancel the R somehow. And to do that, we just have to change this into negative. Right? So AR plus A plus 1, AR plus A plus 1 minus AR plus 1, the quantity AR plus 1. And you can see that this cancels. And so you just have A at the end. But you don't want an A, you want a 1 at the top, right? And as mentioned, the left-hand side. So you just have to divide by A. That's this whole thing. And that's it. That's how you partial fraction. Without doing any of those fancy methods. Okay? Should we write it nicer? And now, let's put it back into the summation. We can extract the 1 over A out. So 1 over A, summation, 1 over AR plus 1 minus an AR plus A plus 1. Okay? And this goes from 1 to N. But notice that AR plus A is just A times R plus 1. Like this, right? So you can see that this is just a method of differences, exactly, with one term ahead, one term difference. So how do you find this? Well, of course, you just copy the 1 over A if you want. That's very fine. And then, well, if you can't really see it, then it's always okay to expand the sum. So let's say when R is 1, then we have 1 over A plus 1 minus 1 over 2A plus 1. Then when R is 2, we just write everything again. And this is 3 because 2 plus 1 is 3. And if you continue it so on, you'll end up at N, right? So when R is N, you have 2N plus 1 minus, wait, is it not, no, not 2N plus 1. AN, sorry. AN plus 1, AN plus 1 plus 1, like this. And of course, you can see that these guys cancel. And so your result is just whatever is left, basically. Okay, I hope I'm not making any mistakes here. Yeah. Okay. And so that's the answer. 4 marks just for these. Actually, you can just do it in 2 lines. Okay. Now that you have this, let's go to the next question. Find the value of A for which this sum to infinity is 1 over 6. Well, the only difference here is that we have an infinity here, whereas we had an n before. So essentially, we're taking n to infinity. So I'll just copy this down again. 1 over A plus 1, minus 1 over n plus 1 plus 1. Well, as n goes to infinity, this term will go to 0, right? Will approach 0. So, well, formally, I should just write it like this. N to infinity. The limit as n goes to infinity is just, well, since this goes to 0, we can just ignore this and write down what's remaining. So that's when you take the sum to infinity. That's the value, I mean. Okay? And now it was given that this value is equal to 1 over 6. So 1 over a times a plus 1 is 1 over 6. And I think it's already obvious. A is 2. So that's the answer. And when a is 2, you have 2 times 3, which is 6. So that's the answer. Okay? Or if you want, you can always make it to a quadratic equation and then solve it. And you'll get a is 2 also anyway. Okay? Right. Is it okay so far? Any questions in this? Any questions in this question? I'll do the questions you guys submitted later, okay? Later, maybe. Like, yeah, later on. No questions, okay? Right. Let's move on then. Why do I have this? Right, so we have the points A, B, C as position vectors here. So this is the A, B, C. They're all relative to the origin. Now we have to find the equation of A, B, C, the plane A, B, C. Giving your answer in the form, yeah, that Cartesian form. It works for A minus 3 as well. Wonder why I specified A must be positive. Yeah, A is positive here. Will there be? Nah, no idea. Maybe just to make things easier, I guess. Okay. Well, if you want to find an equation of plane, then you have to find the normal vector of that plane, right? That's the most important thing to do. To find the normal vector. But to find the normal vector, we need to know two vectors within the plane. So if I have plane right here, then you need two vectors. And then you have to cross product them, right? Take their cross product and you'll get the normal vector. But we know 3 points in this plane, which are these A, B, C. So why not make a vector out of them? Okay? So let's say we want to find AB. So you just have to do minus A plus B, right? Yeah. You're just skipping all the calculations. I think you guys can do it on your own also. Okay, minus 5. Yeah. Okay. But tell me if you think I made a calculation mistake, because I am bound to make a mistake at one point. So imagine if this is A, then this is B and C, yeah? Like that. So you want to find these two vectors starting from the same point, and then you take the cross product to get the normal vector. So same thing. So we find AC this time. Not BC, because that's not going to help. Actually, will it? A, B, and BC. Actually, that will also work, but nah, it's okay. It's more intuitive to do A, B, and AC. Okay, so AC is just, what's it, A, so 0I, because there's no difference in the I. Minus 4 to minus J, that'll be a plus 3J. And then minus 3K. Okay, so these are the two vectors. And now we can take their cross product. So remember, cross product has this form. To find the cross product, you take the determinant of this funny looking guy. Second entry is the first vector. And the third entry is the second vector. Yeah. Okay, I hope you guys know how to find the determinant. Just don't forget this is a plus minus plus. Is it okay if I skip the calculations because you guys can do it, right? Just to make things more minus 5? Oh, oops, okay, thank you. See how, that's one mistake already. It's okay to skip the calculations, right? You know, determinant, you take this guy, determinant of this, then minus J times determinant of this guy, and so on. I hope you guys can do it. And you should get minus 6, minus 24, and minus 24. Yeah. And this is parallel. Well, in normal vectors, we don't really care about their magnitude, and we just have to care about the direction. So we can just show that this is parallel to 1, 4. Just to simplify things, make things easier. Okay? Right, so now that you have this, the Cartesian equation of the plane is basically this ABC. It's just simply these numbers corresponding. So this is the x value, then we put this to the a because it's the coefficient of x and so on. So we should have this form, x plus 4, wait, what is this? X plus 4y plus 4z is equal to d. And we still have to find whether this value of d is yet. And how do you do that? Well, we just need 1 point from the plane. So you can pick any of these guys to use. And let's just say, let's use A, okay? So if you insert A to XYZ, you'll get the value of D. So let's do that. So we have 4 plus 4 times minus 4. Then plus 4. So many 4s. And all of these is just, well, 4 plus 4 is 8. 4 times negative 4 is negative 16. 8 minus 16 is minus 8. So D is minus 8. Hence, the plane is, just you copy everything. That's it. Okay? Not bad for 5 marks. Not bad. Right, let's go to the next part. Find the perpendicular distance from the origin to the plane ABC. Well, visually that means we have to find, if this is the 3D space, and you have a plane here, like that. Well, it's kind of hard to draw, actually. Let's just say the plane is like that, sideways. We'll look at it sideways. So it's this distance here. Okay. But of course, this is actually really easy if you know the formula for perpendicular distance to a plane. From a point to a plane. Just to remind you guys, let's say if you have your plane in this form, and you want to compare it, you find the distance with this point, let's say x0, y0, and z0. Then the distance is just, you take the absolute value of, I'll put it down here, ax0 plus by0 plus cz0, and you transfer this d into the other side, basically. Yeah, this d to the other side. You have a minus d. Divided by the magnitude of the ABC. So you have a squared plus b squared plus c squared. Magnitude of the normal, sorry. Magnitude of the normal. So this is the distance formula, perpendicular distance formula. And since we're finding from the origin, well, the origin is just 0, 0, 0. So I can completely ignore these guys very easily. But what's the d? The d was minus 8, right? Yeah, d is minus 8. So minus d is just 8. So you have 8 divided by the magnitude of what? Of these guys, yeah? The normal here. So 1 square plus 4 square plus 4 square. And that's it. That's your answer. Simplifying it, you get root 3. Or you can put in your calculator 1.39, whatever. Okay? It's not bad for 2 marks. Okay, part C now. The point D has position vector, well, that vector, 2i plus 3j minus 3k. Find the coordinates of the point of intersection of the line OD with the plane ABC. Well, then we have to know what the line OD is. Well, since D is the position vector, that means the direction goes from O to D, right? So this position vector is the direction vector in itself. And the starting point is just the origin. So that means this line is simply just the direction vector times some arbitrary constant. No, not constant, a variable. Yeah, this time variable to make it into a line. And so when does it intersect the plane? That means these coefficients must satisfy the Cartesian equation, right, of the plane. So just to remind you guys, this is the Cartesian equation, like that. And let's expand this. So we have 2ti plus 3tj minus 3tk. Like that. Okay? So that means the idea is that if we put this here, here, and here, it should satisfy the equation. And we have to find the value of t for that. So let's do it. So now we have 2t plus 4 times 3t plus 4 times minus 3t is equal to minus 8. Well, you can see that this cancels already. One is positive, one is negative, so they cancel. And so t is just minus 4. And then you just have to put the t in here, and you'll get your answer. Well, let's do that, actually. So we have 2 times minus 4 minus 8i minus 12j plus 12k. And that is your answer. Or you can write it in point form, minus 8 comma minus 12 comma 12. That's also okay. I think this is more preferred. So yeah, better to write in point form. Okay. Any questions so far? Any questions? Any questions? No? Yes? No? For the first part, can we solve the simultaneous equation? Yeah, you can if you're very dedicated to solving a simultaneous equation. We have 3 points and 3 unknowns. Yeah, you can. Yeah, D is not known. That's the problem. But I think you can just cancel the D somehow. Yeah, maybe you can cancel the D. Yeah, okay. No questions? No one? All right, so we move on, okay? Actually, let me drink first. My throat's gonna be dry if I keep talking. I'm more recovered now. Yeah, thank you. Okay, next question then. We have a sequence of positive numbers in UN, and the first term of the sequence is greater than 4. And it's defined recursively like this, a very scary looking expression, equation. Right, so now we have to show that this sequence is always greater than 4 by math induction. Okay? Okay, so in math induction, the idea is always the same. See if the base case is true. It can be n when n is 0, n is 1, n is 2, whatever the base case is. And then we assume that n is k is true. So assume, yeah. We assume that the case when n is k, where k is just some random integer, is true. And then we now have to prove that it also applies for k plus 1. Yes? Yes? Is there anything? Hello? Can you hear me? You can. It's no, I thought I've been talking to myself the whole time. Okay, thank God. Who are in here? Okay. I hope I can continue, okay? So that's the idea of math induction. Just these 3 things and then you're done. Okay. I'll delete this. Oh. Pause to. Okay. Right. So when n is 1, it's already given to be true. So it's given to be true that u1 is greater than 4 from here. It's already given. So that means true for n is equal to 1. Okay? Now we assume that it is true for n is equal to some integer. So assume true for n is equal to k, where k is some natural number. Let's just call it natural number. And now we have to verify the k plus 1 case. So let and it's k plus 1. Right? So now we have u of k plus 1. Well, by definition, sorry. So we consider the minus 4 because we want to show that this is greater than 4. Greater than 4. If we take the minus 4 of it, we just have to show that it's greater than 0, right? So our target basically is to show that uk plus 1 minus 4 is greater than 0. This is our target. Yeah, so I'll delete this, but it's okay. But the point is that's the target. So we start from here. And by definition, we're already given the recursive definition of the sequence. So we can just copy it. uk squared plus uk plus 12 all over 2 uk minus 4. Delete this first. Okay. And then now you can just combine the fraction together. So you have uk squared. So very ugly looking u. And then minus 8 uk, right? Minus 8 uk, minus 7 uk plus 12 over 2 uk. Right? And then from here, if you notice, the numerator you can factor it, right? You can factor the numerator actually into uk minus 3, uk plus 4, minus 4, 2 uk. Right? So remember that our assumption is that the uk is greater than 4. That's our assumption right here. Our assumption is that uk is greater than 4. Well, so if uk is greater than 4, that means this is positive, right? This is a positive number. This is a positive number because 4 minus 3 is still positive. And surely this is also positive number. Therefore, this whole thing is positive. Hence, we've seen that uk plus 1 minus 4 is positive, right? So uk plus 1 minus 4 is positive. This means that uk plus 1 is greater than 4. So true. So by math induction, true for all n greater than 1. Okay. And if you want to be fancy, you can write this box to show that you're done with the proof. Almost. No idea. I know. Okay. Oh, really? Okay. That's new. That's new to me. All right. Right. Now we just have to show that this sequence is a strictly decreasing sequence. Right? That's what it means. Un plus 1 less than un really just means that this sequence is decreasing. Strictly decreasing. It can never be the same. No two sequences are the same. I know no two terms are the same. They'll always keep going down. Right. So let's do it. Let's just do it straight up, actually. But to make it easier, I think it's better to make everything into one side. So un plus 1 minus un to be less than 0. And we just have to show that it's less than 0 and we're done. So let's do that. Un plus 1 minus un. By definition again, un plus 1 is, well, right there. So we have un. Just change it to the definition, basically. Plus 12. Let me check one more time. Okay. 2un minus un. Yeah, sure. Let's do those questions later. Yeah, I know you like vectors so much. Okay, and then we can combine these fractions together. So you have a 2un squared minus 2un squared. And then we have a un squared right here. Un squared minus 2un squared. Well, it'll just be a negative un squared. Negative un squared. And copy everything else. Okay. And then again, if you notice, that the numerator can be factorized. And that is in this way. Minus 4. Let me see if I'm right. Yeah, it's like this. Yeah, so you can factor the numerator like this. And now let's examine it. So we know that un is always greater than 4, right? That's a fact that we've already proven. That means this is a positive number. This is positive. This is, of course, for sure also positive. This is also positive. So this whole expression is positive, but except for this negative here. So negative times positive is always negative, right? That means this is less than 0. And none. That's it. And so you have shown that the difference of these two terms is less than 0. And just transfer the un to the other side. Okay, and that's it. All right, any questions for this question? Or math induction in general? Anything confusing about mathematical induction? Not you, Alex. You don't need to know. No, okay. How would you do it otherwise for A? Well, just do by UN directly, I guess. But it's easier to consider this because you just have to show greater than 0. You show positive. Yeah. If not for this, then you just consider UN plus 1 directly without any minus 4. Okay. No questions? All right, let's go. Now we have the cubic equation here. Very funny looking one. And it has roots alpha, beta, gamma, as always. If hence or otherwise, always use hence. Well, it's easier to use the hence. I think that's the point. But yeah, the x term is missing here. So there's only an x cubed and an x squared, but no x term. So we have to find the cubic equation whose roots are the reciprocal cubed of the original roots. Right, so this tells us that we have to do some substitution, right? This tells us that we have to do let y is equal to 1 over x cubed. And then we have to find a smart way how to change the polynomial, this cubic equation, so that I can insert 1 over x cubed easily. Well, for now, I can't really do it because there's an x squared, right? There's an x squared here. It's not so nice. Not happy about it. So we have to find a way to do it. All right. Sorry, wait. Okay. So at least how I'll do it, I'll try to move some terms around and then cube both sides. Because I want, sorry, what do you call it? I want powers of x which are multiple of 3 because of this guy here. So let's do that. So I think we can move this 5x squared to the other side. So you have 2x cubed minus 6 is equal to negative 5x squared. And then now we can take the cube. Like this. And good luck calculating this. I already calculated in my head. Well, not really. No, not in my head, but like I know how to expand it. Sorry. So we have 2x cubed squared minus 6. You guys know how to expand a cube, right? I hope so. You know, you better do. No, don't hope. You better do. Like that. Yeah, exam is normal. You better do. Don't say you don't know. Right, now we just have to simplify this. Let's simplify it all, tidy it up. We have 8x power 9 minus 6 times 3 times 4. That's a very ugly one. Minus 3 times 6 times 4. That's minus 72. You're allowed to use your calculator, so yeah, sure. Can we do x? You can. You can. You can. There are actually two methods for this. Yes, you can do that. That is. Wait, there's a minus. Just 1/3. No, no minus 1/3 from what you've written. Yeah, but yes, you can because it's just switching the order of your methods. You cube it first, or you want to substitute first. Up to you. But for me, I cube it first and then substitute later. Okay, let's do some happy simplification. 36 times 6. That's 216. X cubed minus 216. Okay, just like this. And then transfer this right-hand side to the left-hand side. So yeah, we get a tidier equation, a neater-looking equation. 125 minus 72, right? 125 minus 72 here. We have 53. So many computation. It gets very tiring and more prone to mistakes. And now, since everything is now a multiple of 3, the powers of x, you can do the substitution now. It's much easier. It looks more neat now. So yeah, basically this, if y is 1 over x cubed, then x cubed is y. X cubed is 1 over y. Okay, now we have, well, just change everything basically. But remember, you want a polynomial, you don't want a 1 over something. So just multiply both sides by y cubed. And you have your answer. What the hell am I writing? Okay, and that's the answer. Okay. It is very easy to make mistakes. Even sometimes I'll make mistakes in these kinds of questions, especially with these ugly numbers. But it is what it is. You can also take the negative of this equation. That's also fine. So you have a positive coefficient in here. That's fine. Nice question. It's very computational. Right. Now we have to find the value of the reciprocal of the roots power 6, basically. Well, of course, it is much easier to use the equation that we got, right? And start from there. That's basically the S2. Do you guys use this notation, S2? It's the S2 of this equation right here. Okay. Right, so before we begin, we want to have a monic polynomial first. That is, we want a coefficient of 1 here. So we just divide both sides by negative 216. So you have y cubed minus y squared minus 53 over 216. Yeah, it's a very ugly number. I know. And then, what's a divided by 216? No, okay. 1 over 27 equals 0. Okay? And just as usual, when you do these kinds of polynomial questions like this, finding roots, blah, blah, blah. Personally, I like to do plus minus plus. I'll write this down. I don't know if you're taught this way, but I hope you get what I mean. Anyways, well, if you want to find the S2 of this equation, then you have to find the S1 of this equation, right? Actually, I should write S1 prime. S1 prime just means 1 over alpha cubed, 1 over beta cubed, plus 1 over gamma cubed. So the S1 is just this guy, right? But you times the negative here. The coefficient of the y square times negative 1. Well, negative of the coefficient, basically. And that's just 1. And then you're supposed to find S2 here, S2 prime. But that requires the square of S1. So we have S1 prime square minus twice of the double product of roots, right? The double product of roots. Well, essentially this is just like that. But for in our case, because the roots are 1 over x cubed, then I write it this way. But anyways, this is just this value right here. It's basically just negative 53 over 216. So we can just plug in and solve. And yeah, simplify. 1 squared minus 2 times minus 53, 216. Like this. Very ugly number. And if you simplify it, of course, you can use your calculator. You get 161 over 108. Okay? 3 marks and 3 marks. Okay. If you guys have any question, just submit it in the chat. Yeah. Psychologically less intimidating if we write. Yeah, that's less intimidating. Okay. Sure. Okay. So part C now. Now we have to find the power 9. Well, the power 9 is just S3 prime, right? In this case, it's just S3 prime. And to do that easily, we just have to use our polynomial again. Once more. I'll copy paste it. Right here. And remember that if you have these kinds of polynomial, then we can change the variables into the sum, right? Well, if it's a y cubed, then it becomes S3. So this is S3 prime, that's S2 prime. Looks like a 5. This is S1 prime. But remember, do not forget to multiply by the degree of the polynomial for the constant term. Because the reason why this works is because when you add all of these up together, right? And there are 3 equations, so you add them up. So you multiply by 3, basically. This one by 9 is equal to 0. So don't forget about that. And now, if you now find S3 prime, just transfer everything to the other side and solve for S3. So S3 prime is when you transfer everything to the other side, basically. I'll just steal this guy. Oops. I hate this. So bad. And plus. Okay, and you just have to put S2 prime, S1 prime. What was this before? 161 over 108. This is just 1. When you add them up, you should get 133 over 72. Like this. And can you verify? It should be right. Yeah, okay. Okay, thank you. Okay, 2 marks. That's it. Any questions here? No, right? I mean, if you do have, it's okay. No questions? All right. All right then. Curve sketching. I'm very tired of curve sketching. The curve C has this equation here. We have to show that C has no vertical asymptotes. And state the equation of the horizontal asymptote. Well, vertical asymptotes happen in the first place because the denominator is 0, right? If there are no vertical asymptotes, that is an if and only if the denominator is never 0. So you just have to show that the denominator is never touches 0 in the first place. So that is the x squared plus x plus 1, right? This guy here is equal to 0. To show that this has no real roots, we just take the discriminant. So 1 squared minus 4 times 1 times 1. That's minus 3. And certainly less than 0. So no real roots. Real roots. This implies that no vertical asymptotes, no v asymptote. So allow me to be lazy. What about horizontal asymptotes? Horizontal asymptotes happen when you take the limit to infinity, right, of this rational function. Actually, to both sides of infinity, plus and minus infinity. But in this case, they're actually the same. So limit as x goes to plus minus infinity. Like this. And that's just 2. So the horizontal asymptote is y is equal to 2. This is the horizontal asymptote. Right? Okay. Yeah, I see that you're typing. It's okay. I'll wait for you to type. Or if you don't want to type, maybe not. Right? Okay. Now we have to find the coordinates of the stationary points of C. Of course, maybe the natural thing is to find the derivative, find dy dx equal to 0, and then call it, and then yeah, equal to 0. Find the values of x, find the value of y. But let's try another method here without any derivatives. Okay, so instead of taking derivative, I'm going to multiply this to your side. So here we have y x squared plus 1, x squared plus x plus 1 is equal to 2x squared minus x plus 1. Sorry. Right, now we bring everything into one side. Let's say we bring everything to the left-hand side. Then we have y minus 2, x squared, and then y plus 1, x. Basically just, combine the terms, the like terms. And y minus 1. And now we take the discriminant of this. We take the discriminant. So we have y plus 1 squared, minus 4, y minus 2, y minus 1 is equal. Well, we don't know if it's equal to 0. No, not equal to 0. Okay, so how do you simplify this? Let's just simplify this first. So we have y squared plus 2y plus 1 minus 4. Let's see, y squared minus 3y plus 2. Simplify one more time. 3y squared. 3y squared, right? Then 14y minus 8 plus 1, so minus 7. Right, is this correct? I hope this is correct. Let me verify one more, just to be sure. No, I don't think this is correct. Did I make a mistake somewhere? Oh, wait, AC. Eh? What am I? Hmm? Oh, crap. This should be a minus. Sorry. This is a plus. This is a plus. And so this has to be minus y, minus 2. Yeah, okay. Should be correct now. 4 plus 6y. 8 plus 1 minus 9. Okay. Okay, this is better. Okay, just like that. Right, so we're essentially asking, when does the y exist in this rational function, right? So we want to find when this discriminant is greater than 0. Or basically, if you divide by -3, we're essentially finding when this is less than or equal to 0. Okay? Sorry. Yeah, did I make another mistake here? Oh yeah, another mistake. Oh my god. There you go. Okay, so you can factorize this into y minus 3 and y plus 1 less than 0. So therefore, this value of y must be in between -1 and 3. If you forgot the reason why, you can always draw the graph. So this is the critical points is just -1 and 3. Those are the roots. This is -1, 3, and if you draw the graph, it's right here. I'm sorry, I'm very bad at drawing. I hope you get the point. And when is it less than or equal to 0? Well, it is in this region though, and that's why that's the answer for the y. But remember, we're not looking for the when does y exist. We're looking for the stationary point. So when does the stationary point happen anyway? The stationary points happen when it's equal to 0. So basically, it's these two guys actually. Stationary point occurs when y is equal to 3 and y is equal to -1. And then from here, you can find the values of x. So that is 0, -1, and -2, 3. You can find it on your own. Okay? Do you know the reason why, by the way? Do you know the reason why double root, when it's equal to 0, is a stationary point? Do you know why? Say if I draw the graph. I don't know how the graph looks like yet. But if I draw the graph, what am I actually doing all these time? Sorry. The question is, do you know why the stationary point occurs when the root when it's equal to 0? Discriminant is equal to 0. Basically, you have a double root. Basically, do you know why? Yeah. Okay. Okay. Good. I don't have to explain that. Yeah. No plus minus, so there's no two values. Stationary point means that the y, the horizontal line just touches the graph ones. Yeah. Making the y in the axis. Yeah. Making the y in the axis basically. Okay. Okay. Now we have to sketch C. I'm very lazy to sketch. Of course, give out the plus sign. And now let's use all the information we have all this time. First, we know that there's a horizontal asymptote at y is equal to 2. So let's say this is 2. And say this is the line. Like that. So that's a horizontal asymptote. There are no vertical asymptotes, so that's fine. No worries about that. But we know that there are two stationary points, which are these guys here. 0, -1, -2, and 3. Sorry. So 0, -1, maybe if this is 2, then this is -1. So there should be a stationary point here. And then what's the other one? -2, 3. So -2, let's just say this is -2. I don't know. And 3 should be up here. It's a bit above again. This is 3. Should be a stationary point here. Okay. All right, so if we draw the thing, yeah. Actually, no, before that, I think it's best that we find the intersections to the x and y axis. Well, the y-axis is basically here. We already know it's a stationary point. That's the intersection to the y-axis. But for the x-axis, then we have to let y equal 0. Let's solve it here. 2x squared minus x minus 1 is equal to 0. And what are they? Should be 1 and minus half. These two guys here. Yeah, you guys can solve this on your own, yeah. No problem, I think. For math students, you guys can do it. Okay, so now we have x is 1. 1. This is 2. What the hell? 2. So it should touch here. And one more, it should touch at minus negative half. So right here. Okay, now you just draw the graph like there's no tomorrow. Found to die. It's so hard. Okay, like that. Okay, can you use dy dx? Yes, you can. That is the most natural way to do it. Use dy dx. But I am very lazy to do computation. It is so tiring for me to do computations like that. And I'll make mistakes along the way anyway. Is the adjoint of matrix A equal to cofactor matrix of the transpose A? Yes, yes. You cofactor matrix and you transpose it. That's okay. That is, yeah, it's correct. Sometimes it's called the aggregate matrix. Cofactor matrix of the transpose. We usually take the transpose of the cofactor matrix. Oh, transpose of cofactor matrix. Yeah. And then you take cofactor matrix of the transpose of A. I don't think so. No, I don't think that's gonna work. I don't think, does it work? I actually haven't thought about it. Adjoint is cofactor. I don't think so. I don't think so. Okay, I don't think so. But I'm not sure, but I don't think so. I don't think so. It works for 3 times 3, 4 times 4, 5 times 5. Yeah, but yeah. Actually, it might be an AS. But okay, whatever. All right, so to draw it again, we have to sketch the curve this time with an absolute value. Let's have the absolute value here. Sorry. Q7b, yeah, later. Shush. So with the absolute value, then of course it doesn't touch the, what do you call it? It doesn't touch the negative realm, then the half plane basically. So we don't have to care about the negative values because it'll just bounce back up. And so we just have to draw it again. So if this is 2, just draw it, ding, like that. Okay. And now we have to find the set of values for which this, if you equate this to k, this whole thing to k, it has 4 distinct real solutions. Well, that means it has to intersect 4 times. 1, 2, 3, 4. Yeah. So I think we can see that it happens in this region here. So in these set of values, we have 4 solutions, right? So that means the k cannot be 0. It has to be greater than 0. But also less than whatever this value is. But we know that it was minus 1 before. When you take the absolute value, it's 1. So this is actually 1. So k is between 0 and 1. That's the answer. Okay. Next, let's go next. Polar curves. I almost forgot polar equations exist. It's been a long time since I deal with polar stuff. And this is my first time doing it again after forever. The curve C has polar equation. R squares tan inverse of half theta. No polar at university. Well, at least my course doesn't have. But the other courses, like the regular calculus 2, they do have. Regular calculus 2 has. My calculus 2 doesn't have. Polar integration, yeah, it's ugly, but we have to do it. Okay. What? Sorry. All right, so we have to sketch this polar equation, and we have to find the greatest distance. Okay. Well, the theta goes from 0 to 2, so I don't really have to care so much about about the bottom left of the plane, I guess, like this. And theta is equal to 2 is like somewhere here. I don't know. It's surely bigger than pi by 2. So it should be somewhere there. I don't know. Somewhere here. Let's just say here. Okay. First of all, the actual equation is like this, right? For positive theta. Surely when theta is 0, then the r is also 0. So it should start from here. Makes sense. And then tangent inverse is a strictly increasing function. Tangent inverse, if you remember the graph, it should look like that. Like that. Whatever. So if you square root it, I think it's still gonna be strictly increasing. But the rate of change at near 0 is gonna be a bit sharper. If you square it, it'll be a bit sharper. Like maybe like that. It'll be just a bit more up, like even sharper. Okay. So if you draw it, then you should have a sharp looking curve at the beginning. It should look like something like this. Oops. Like that. Something like that. So yeah, it's a bit sharp here. Basically, it gets tangent. Basically, it's like a tangent line at this point. So what's the greatest distance? Well, the greatest distance is just at the end of the interval, right? Because tangent inverse is increasing, so the r increases. It happens at the very end of the theta, which is when theta is 2. And when theta is 2, well, you halve it, you get 1. That's pi by 4. So therefore, the greatest distance is square root of pi by 4. Okay. Find the exact value of the area of the region bounded by C and the half line theta is equal to 2. Basically, this region here. So of course, we have to do polar integration. Everybody's favorite. So just to recall, the formula to find the area of a polar region is, what the hell? Sorry. Half the integral of r squared d theta. If you can't really remember the area formula, just remember the area of the sector of circle. Half r squared theta. This is the area of sector of circle, right? Or if you change the integral form, then you just do this. Okay, if you forget, then that's the mnemonic to remember it, I guess. Yeah. Okay, so using this, let's do some integration. So we have half, and the integral, well, where does the integral go from? Well, the theta goes from 0 to 2, so that means our integral should also go from 0 to 2. 0 to 2. But what's r square? Well, we already have r square here. This is our r square. So let's put that down. Tangent inverse half theta. And so if you evaluate this, you should get the answer. Do you want me to evaluate it? Or can you do this by yourself? Do you guys know how to integrate a tangent inverse, right? Why not? Well, the only reason why not is because I'm lazy, but if you want, then I don't mind. Just because I like integration doesn't mean I like to integrate these kinds of functions. It's very tedious. It's just tedious. But all right, fine. I'll do it. Right, so if you have a tangent inverse, well, the idea is basically, maybe I'll not do it fully, but I'll just give you the idea. Tangent inverse means that you have to do integration by parts. You differentiate the tangent inverse and integrate one, right? So you have half theta tangent inverse, half theta. Sorry. So from 0 to 2, of course, runs from 0 to 2. I'll delete this guy first. Minus, and then you differentiate tangent inverse. So now you have half theta times differentiation of tangent inverse. Tangent inverse is 1 over 1 plus x squared, but our x is just half theta. And then also with the chain rule, don't forget to multiply by half by 1 over 2. So now you have this. And then from here, I think you can see that this is just the derivative of ln, right? Just derivative of ln. Then you integrate normally and you take the difference, and I think you should get the answer. Okay? It's just all calculations. I hope you guys can do it. Tomorrow's your exam. You better know how to do it. Right. Okay. Must be tempting. Yeah, it's tempting. But no, I'm not writing it. Next question then. Consider the part of C where it's just the first quadrant. So from 0 to pi by 2. So you just have to care about this part here. Just this part. And we don't care about this one. Show that at the point furthest from the half line, that equation is true. Okay. So let's understand what it means by at the point furthest from the half line. So if I draw it here, well, the half line, pi by 2, is just up here. And remember that the graph looks like this. Something like that. I don't know. So the point furthest from the half line just really is asking what's the furthest x coordinate. So it should be at this one here, right? This one here. That's the furthest one, basically. So that means we have to deal with x values. In polar coordinates, to find the x value is just, you multiply by cosine, right? The r times the cosine. So we have x is equal to the r cosine theta. But then remember that r squared is tangent inverse. So the r is just the square root of the tangent inverse. Tangent inverse half theta cosine theta. Okay, so that's the x. So once again, we want to find the furthest point. And if you notice, the furthest point just really means it's a stationary point, right? That means we have to take the derivative. So we have to find dx d theta. God help me. Right. So product rule. We have a product of two terms here, root of tangent inverse times cosine theta. Let's differentiate the root tangent inverse first. By the chain rule, the derivative of the outside function is just 1 over 2 root blah, 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 right? 1 over 2, in this case, tangent inverse half theta. And then we have to multiply by the derivative of tangent inverse. That is half plus 1 over half theta squared. Then times cosine theta. And then add it with when you differentiate cosine instead. Differentiating cosine is just simply negative sine theta. And so you have your result. Like this. Since we want to find a stationary point, equate it to 0. Equate it to 0 here. And good luck in solving. Well, and actually, it's good luck to me because I have to do it. Right, so we just have to care about this part here. Right, so from here, we can see that if I multiply by square root of tangent inverse, that'll make things nicer. So we have And this half multiplied by this is just 1/4. So we have 1/4 times 1 plus, 1 plus half theta square cosine theta minus sine theta tangent inverse half theta. Okay. Okay. Now that's done. I think we can simplify this part again here. If you notice, I can multiply both numerator and denominator by 4. And so we get 1/4 plus theta square. That's what Alex was talking about before. And then finally, well, if you see that the theta square plus 4 is at the numerator part, not the denominator. So it really just tells us that we have to multiply both sides by theta square plus 4. So let's do that. We get cosine theta minus theta square plus 4. Sine theta, tangent inverse, half theta. Equals 0. And multiply by negative and you'll get your answer. Okay? And how do you show that there's a root between 0.6 and 0.7? This is just like normal math. Normal pure 3 math. Just put 0.6. It'll give a negative number, maybe or positive, whatever. And 0.7, it'll be the opposite sign. And you just say that, oh, there's a change of signs. So there's a root in between. That's it. Okay? Okay, yeah? Part A. This one, part A. Sketch. Sketching, right? Sketching is basically, the idea is just, you just try to study the function tangent inverse half theta. And yeah, you study the function basically. Well, it is a strictly increasing function, so your R should increase over time. Yeah, theta 2. Oh, theta max distance, yeah. Well, tangent inverse is always increasing. It never goes down. So the bigger your input is, the bigger the value, because it is an increasing function. Strictly increasing even. That means if you put theta as 2, it gives the max distance. Do you get it? You want to put the theta as big as possible, because that will give the highest distance. Okay? Okay. Right, last question. The funny matrix question. Find the set of values for which that we take calculus mode and rather degree radians. Polar equation is always radians, no matter what. Okay, do not use degrees in polar. Okay, good. Right, find the set of values of k for which a is non-singular. So of course we just have to take the determinant. This determinant of a, that a. You can't get negative area via polar integration. Yeah, you can never get negative area because you have a square in the first place. Because it's r square. You're integrating r square. R square is always positive no matter what. So you can't get a negative area. Yep, okay. Right, so we want determinant of a not equal to 0. So what's the determinant? So let's find the determinant actually. I'll move this aside. I guess we can do the normal method. Just do plus minus plus here. And take the determinant. And I hope you guys know how to do determinants. So k 6, 8, 9 minus 2, 4, 7, 6, 9. And finally 3, 4, k 7, 8. Okay, I hope you guys get this. And we don't want this to be equal to 0, so not equal to 0. Simplifying the left-hand side. I'm not going to do it by hand. You guys know how to do it. It'll become negative 12k plus 60. It's not equal to 0. So that means K cannot be 5. Just solving the equation. It's not an equation if it's not equal, so unequation. Solve the unequation. Just a joke. Okay, so basically the value of K is basically 5. Oh, wait, sorry. We want to find the value where K is non-singular. Oh yeah, sorry. Okay, so this is the correct answer. Yeah, K is not equal to 5. I forgot it's not asking for when A is singular, because if A is singular, then that's it. Okay. Given that A is non-singular, find in terms of K the entries in the top row of A inverse. And this is where you use the adjoint matrix. Can we say that if the numbers from R to L and T to B form AP, then it's singular? R to L and T to B? Yeah, just the first column, basically, yeah. But that's the idea. The idea is from the adjoint matrix. Right, singular, so therefore, okay. If the numbers from R to L and T to B form an AP, arithmetic progression, okay, that's singular. Right to left, top to bottom. Right to left, top to bottom? So 3, 2, 1, 6K4, 987. That's right to left, right? Right to left, top to bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, forms a singular matrix. Oh, all right. But no, it's just a special case. No, I don't know. I never thought about it. Never thought about it. Oh, okay. Maybe, but I have no idea. Okay. So just to you guys remember, there are, well, A inverse you can find it by doing augmented matrix. And then my method marks shaped. Okay. You can do it by augmented matrix to find A inverse, but actually there's also another way to find A inverse, and that is A inverse is 1 divided by the determinant of A times the adjoint of A. So the adjoint of A is our matrix. Determinant is a number, just a real number. Okay? And the adjoint matrix is basically the cofactor matrix. It's just the cofactor matrix, and then you transpose it. How do you write the cofactor matrix again, actually? Right, like M11, M12, M21, and then you transpose it. No special notation. Oh, that's sad. All right, so I guess that's adjoint then. So it's the cofactor matrix, and then you transpose. Okay. So that means if the value, the A inverse, actually, so I'll write that one more time. So this is M11, M21, so on, M12. I just transpose it, basically. I just transpose it. And I hope my notation's correct. My 1, 1, 1, 2, 2, 1. I hope they're correct. Yeah. Okay. Right. So if you want to find the top row of A inverse, you have to find M11, M21, and M31. Right. So M11, M21, and M31. And this is what you want to find. So where's the matrix again? Okay. So what's M11? M11, M21, M31. Yeah. Let me just write the matrix down again here. 4, 5, 4K, 6, 7, 8, 9. Okay. So to find M11, well, where is the coordinate 1, 1 in this matrix? 1, 1 is basically this entry. Just like usual, you basically take the determinant of what's left, just like how you would take the normal, determinant as usual. Let's ask for bottom or middle. What do you mean for bottom or middle? I don't understand. I don't understand what you mean by bottom or middle. Rows? What is asked? We just middle, the bottom and middle rows. If it's middle rows, then you just have to take this one here, this one. So it's M12, M22, M32, and so on, basically. Basically, you just use the adjoint matrix and see what you need to find. In our case, we just went on the top row, so we take this one. If you're in the middle row, then we take this one. Bottom row, then take the last one, the very last row. And you know what, and you can check what you want to find. Okay? That's how you do it. Okay, so just to repeat, M11, this is M11, take the determinant of what's left. Therefore, M11 is just K689, determinant of this guy. And what about M21? After taking the transpose, because that's the adjoint matrix. The adjoint matrix is after taking the transpose. Okay, so M21, be careful here. M21 is not M12, so M21 is right here. Not this one, not this one. So it's this 4 here. But you just check one more time. Did I make a mistake? All right, okay. Okay. So this is M21. This is the entry, the 2-1 entry. So deleting this, that means we have to take the determinant of what's left. That is 2, 3, 8, 9. And unlike when you take the determinant before, you don't have to multiply by this number. Yeah, you don't have to multiply by this number. So just the determinant of what's left. No multiplication of anything else. And lastly, M31 is this one. So determinant of this matrix, K6. I'll bring this down actually. So how do you find the top row? Well, the entries of the row. As you remember, we have the adjoint matrix. So we already have the terms in the adjoint matrix here. We already have the terms. So all we have to do is divide by the determinant. So, right, we have to divide by the determinant. So you just have to multiply by 60 minus 12k in both sides. 60 minus 12k over 60 minus 12k. And so these are the terms here. All of these are the terms. Actually, I'll write this in the... Yeah, okay. That's better. So these are the terms, and I hope you guys can simplify it, okay? Just take the determinant, simplify, everything. What about the sign? Oh, right. I'm sorry. I forgot the sign. I forgot the sign exists. Sorry. Okay. So the sign still follows as usual determinant rules. So this is still plus, minus. I'll put in red. Sorry. Thanks for reminding me, actually. Plus, minus, plus. Just like a checkerboard, you can continue it. This is plus, minus, plus. Sorry, not plus, minus, plus. Minus, plus, minus. So it's like, yeah, like a checkerboard. Plus, minus, plus, like this. So actually, there should be a negative here. Thanks for reminding. Yeah, this one. So all of these are the terms. Thank you. Okay, next page. Given that B is that funny-looking matrix, give an example of matrix C such that BAC is 2, 1, K4. That means, well, we're given BAC. We know B, we know A. Why not multiply them together first? So we have 1, 0, 0, 1, 0, 0 here times A, 4, K, 6, 7, 8, 9. Like this. Okay, if you multiply this matrix, you'll get 1, 2, 3, 4K6. Basically, you're just deleting this row like that. And now you're going to find a matrix C such that when you multiply them together, this is C right here, it'll become 2, 1, K, 4. Right, if you notice 2, 1, K, 4, it's just when you get this matrix and you switch the columns. You just switch the columns. So let's try to find a C such that when you multiply it, you get it. Well, first of all, this is a 2 times 2 this is a 2 times 2 matrix. This is a 2 times 3 matrix. Therefore, C has to be a 3 times 2 matrix. Okay, so it must be a 3 times 2 matrix, something like that. And now, what is the value of C so that I can get these values? Okay. So, well, since the values are the same, for sure that my C will be only filled with ones and zeros. Yeah, zeros and ones. So let's see. To multiply, to get this value here, then we have to do the top times the left side right here. Right, to get the 2 in the right-hand side, we need to get the top of BA times the left column of C, basically. And you get 2. And so how do you get 2? Yeah, so that means this has to be 0, right? Because we don't want a 1. 1 times 0 is 0. But we wanted 2. We wanted 2, so we put a 1 here. And we also don't want the 3, so we'll put a 0 here. So you see that if I multiply these guys together and add them up, of course, you get 2. Because we have removed the 1 and 3 by multiplying by 0. Yeah. No, you cannot multiply by inverse because there's no inverse for a 2 by 3 matrix. Yeah. There is no inverse for non-square matrix. That's correct. Okay. And lastly, let's just verify to see if we can get K also here. So 4K and 6 times this column here. And that's also, and you see that the 4 is removed, 6 is removed because of the zeros. And so what's left is just K times 1, which is K. And finally, same thing for the right-hand side now. Let's say we want to find 1. We don't want 2 and 3. We only want 1 to 1. So therefore, we have to put the 1, 0, 0 here. Yeah, like that. So that's the idea, okay? That's a very simple idea on how to solve. And so this is the answer. Okay. Okay, let's go next. So we have so many pages. Okay. Find the set of values of K for which the transformation in the XY plane represented by that matrix has two distinct invariant lines. Sorry. When I do invariant lines questions, I always try to remember TMT, T and MT, because that's what you have to multiply with later. So we have 2, 1, K4 multiplied by T times MT. And that is equal to another set of T, this, of a capital T times M big T. That's how I've always done it. Sorry. Yeah. Okay, now we can multiply the left-hand side to get 2T plus MT. And then that's the top entry. And now the bottom entry is just KT plus 4MT. This TMT. So you actually have a simultaneous equation here. This is actually a simultaneous equation. I can remove the matrix actually here. Put an equal sign. And now it's a simultaneous equation. And now you can divide the two equations together. So you cancel the t's. Both capital and small letter t's will get canceled. So you have 2 plus m over k plus 4m is equal to 1 over m. And then now you can solve for the m. So you have 2m plus m squared is equal to k plus 4m. So you have minus m squared minus 2m minus k equals 0. Well, you're going to find the values of k for that so that it has two distinct invariant lines. Sorry. So that therefore it's basically asking when does this quadratic equation have two roots? Therefore, we have to take the discriminant. So we have minus 2 squared minus 4 times 1 times minus k is greater than 0. So 4 plus. Okay. Why are you asking that question here? I don't know. Yeah, k can't. So actually, the k can't be 8. And what's the reason, actually? Actually, I'm also trying to find out the reason. Let's see. If k is 8, then this determinant is 0. That's for sure. I can see that the determinant is 0 when k is 8. What does that have to do again? No, I forgive him. I forgive him. It's okay. I forgive him. He's just doing his best, you know. It's stressful to do further math. You just have to de-stress. That's why he asked that question, maybe. But yeah, when k is 8, the determinant is 0. And so there's a mapping. I don't know how to say it, but the mapping will be the same when k is 0, when the determinant is 0. It's another one-to-one mapping, basically. It just squishes the 2D plane into a line. And so you have a non-distinct line. Yeah, non-distinct invariant lines. When k is 8. So k cannot be 8 also. I can start. No, I don't need. It's okay. I don't really need a break. No real solutions. Well, the point is we want real solutions. So k has to be. Yeah, the discriminant has to be greater than 0. When k is 8, it's not about the problem of real solutions or not. It's the problem of the determinant of the matrix is 0. This matrix here, the determinant is 0. 2 times 4 minus 4 is 0. Sorry, 2 times 4 minus 8. Sorry, 2 times 4 minus 8 is 0. Knowledge of linear limit to F1 doesn't include this. Yeah, I guess. I'm not sure if they explained it somewhere. Is there a better explanation as to why? Let's see. When k is 8, maybe there's a better way to see it instead of the geometric way to see it. This is 8. Oh, no, you can see, I think you can see the reason why here. 2 plus m over 8 plus 4m, that's just 1 over 4. So m is 4. But then when m is 4, so what? What's the problem with that when m is 4? Sorry. Other than the geometric way of seeing it, when m is 4, oh yeah, it's just one value. Yeah. We want two values of m, but there's only one value of m, so it can't be counted. That's the reason. Okay, now I know it. Yeah. Yeah, matrix is singular, but what's the reason here? That's what I'm trying to explain here. Well, basically, you want two distinct invariant lines. So the m, you need to have two values of m. Yeah, two values of m. There's one in terms of FP2. But in this case, when k is 8, the m there's only one value of m. Yeah. You can get two values? I thought it's just one. No? This is not one? Plug in the quadratic. I guess in the quadratic, but let's see. 4 square. Plug in the values in quadratic. I guess it's 2, but wait, let me see. Maybe I have done something wrong again. Minus 8. You get two values. Minus 2. Minus 2? Hmm? Yeah, m is minus 2. But then when m is minus 2, 4 when m is minus 2, I guess? What's the reason? 0 eigenvalue. We don't talk about eigenvalues in FP1. But okay, but yeah, that's valid. That is valid. Yeah, the problem is when, let's see, is eigenspace stuff, but we don't talk about that in FP1. And please don't intimidate the FP1 people. Yeah, that's not an AS. That's not an AS. Don't worry yet. That'll be in your A2 next time. Eigenspace, just eigenvalue, eigenvector. Soon part 2. um, so what's the reason? Is there a better way to explain this? This time for you, yeah. If you do it here, the m is only one value. So what's the reason? I guess, I don't know. In the quadratic, you get two values. But in this part here, you only get one value. Because, well, this is the original one that we want to solve anyway. So I think we have to follow this one more. You get one value for m. I think we have to focus on this equation here and not this one. Because when you multiply, remember when you multiply by a factor, a factor, then you'll have two values. Assume m isn't 0. Yeah, you basically assume that, yeah, it isn't 0. Because let's see. Well, in this case, when m is 4, then you have this. But if you multiply both sides, just cross multiply as usual, you get m squared plus 2m, m squared 4m plus 8. You'll get another new value. Yeah. I'm still convinced it isn't a fair question. Yeah, I guess it's not a fair question. But that's the idea. Yeah, that's the idea. Well, what's the difference empty and empty? Is there any difference? You will have to like 2 lines. No, I don't think so. Oh, has only touched partly of chapter 1 A2. Oh, your teacher's going really fast then. Okay. But yeah, when you multiply, when you do cross multiplication, the problem is that this is actually a constant. So when you multiply, you'll have two solutions. That's the problem. You guys have teachers? Yeah, you guys have teachers. I even had to self-study back then. I had to self-study back then, yeah. Your teacher's better than me. I'm just here to give review. Wait here. Yes, I'm waiting here. I'm not going anywhere. And T1 is equal to 4. Oh, yeah. I guess so. Ow. That hurt. Right, we've finished the whole question, basically. The whole paper. Congrats.